The next question. Consider reversible systems at constant temperature at an equilibrium in a vessel of constant volume. Volume is kept constant, temperature is kept constant. In a particular closed vessel, these two reactions are at equilibrium. What are the two reactions? SO2 gas plus Cl2 gas giving SO2 Cl2 gas is the one system. And another one is CoCl2 gas, carbonyl chloride gas giving CO gas plus Cl2 gas is another system. These two systems are there in the same vessel at the same temperature at an equilibrium state. Now, at equilibrium, few more moles of CO gas are added. So, we are increasing the number of moles of CO gas by adding moles of CO into the vessel. The new equilibrium concentration of. So, the moment more moles of carbon monoxide are added into the system in a closed vessel at constant temperature, this CO moles added to the system which are at equilibrium. We are disturbing the equilibrium by pumping more moles of CO gas. So whenever the system at an equilibrium is disturbed, the system will be disturbed for a momentary and then try to regain the equilibrium. So at the regained equilibrium, that is new equilibrium, what will be the concentrations of the substances? Is it that SO2 concentration will be less than what it was? SO2 will be same as original concentration. C says SO2 will be more than what it was. And Cl2 will increase. In other words, the concentration of Cl2 will become more. What exactly will happen if CO is added to the system at equilibrium at constant temperature? Since this CO is already there in the second equilibrium system on the right hand side, when we are increasing the concentration of this CO, according to Le-Chatelier's principle, the equilibrium shifts onto the left hand side. So if we consider the second system, that is CoCl2 gas giving CO gas plus Cl2 gas. The moment carbon monoxide gas is added into the system at equilibrium, the concentration of the CO increases. Thereby, the equilibrium shifts on to the left hand side. In other words, backward direction reaction is favored according to Le-Chatelier's principle. So the moment the backward direction reaction is favored, what's happened to this chlorine gas? As the backward direction reaction is favored, carbon monoxide reacts with the chlorine and the concentration of this chlorine decreases. And the moment the concentration of chlorine decreases, as we have in the first system, SO2 gas plus Cl2 gas giving SO2 Cl2 gas. This system is also there in the same vessel at same temperature. And as the concentration of this chlorine decreases, as per the Le-Chatelier's principle, so as to produce more amount of chlorine, the backward direction reaction will be favored. So even in the system 1, the backward direction reaction is favored. Means what's happening? SO2 Cl2 gas goes on decomposing to give more and more amount of SO2. Therefore, the concentration of sulfur dioxide as the backward direction reaction is favored will increase. That is, the concentration of SO2 will now become at new equilibrium. Thereby, it is more than the concentration of SO2 at original equilibrium before carbon monoxide gas is pumped into the system. So thus, the concentration of SO2 will increase, become more than what it was at initial state of equilibrium. Now, let us see the various options given and let us choose the correct answer. So SO2 will become less is wrong. SO2 will be same as original concentration. No, it's getting disturbed. SO2 will become more. So therefore, the concentration of SO2 will be more than what it was at original equilibrium. And what about the chlorine? Because of the disturbance in chlorine only, SO2 will be becoming more. So thereby, the answer D is wrong and C is right.